Works this time.
Are you recording, Kelly?
I am now, yep. Okay, it probably didn't record all that because that was the program crashing. Okay, let's see if it works this time. It does. Okay, f prime equals. So I take the derivative of the top. Oh, it's kind of weird again, isn't it? Small. That's fine. F prime here is the derivative of the top. Does anyone remember what the derivative of tan x is? It is secant squared x. So that's the derivative of tan. So I write secant squared x times x minus the derivative of the bottom. What would the derivative of the bottom be? 1 times tan x all over g squared, which would be x squared. Okay, so a bunch of you guys were asking me, and I think I corrected all of it, but just in case I didn't actually talk to anybody, if you have something like secant squared x times x, that's not secant squared x squared, like you can't multiply the two x's together, the x that's with the secant is inside secant. It's like there's invisible brackets that we don't draw, but they're like this, and that x can't be done, nothing can be done with it. You can't bring anything inside of a trig function. There's no way to do that. So this really is just, usually we'd write it as x secant squared x, secant squared x minus tan x over x squared. And there's nothing you can factor out or anything. I see students a lot of times will try to factor out those x's, like the secant x and the tan x. You can't factor that out. There's nothing to do with that. Remember that tan and secant are just operations, so there's nothing you can do with it. Then we have to type in, we have to get f prime of 2. So we need f prime of 2, which will be 2 secant squared 2 minus tan 2 over 4. That is not something that I would expect you to know in your head or anything like that, so don't be too concerned about having to have it memorized or be able to do something like that. You would just type that into a calculator. So f prime of 2 is whatever that's equal to. I don't have my calculator on me. I don't think I have a calculator at all, actually. I had a TI-84. Does anyone know where my TI-83 is?
Didn't you borrow it last night?
Probably.
I think you gave it back.
I have my pink one. I just don't have the... Okay, now how would you even type in to your calculator? I imagine there'd be some people have trouble. How could you type in secant squared 2 into your calculator? Yeah, it's 1 over tan. No, see, it's 1 over cosine. So you type in 2 times 1 over cosine 2 bracket squared. Okay, so you type in, I'll just put it down on the board so you can see it, 2 times 1 divided by cosine 2, and you put your bracket squared on the outside. Okay, that's how you type that in. It's a little hard to type. Minus tan 2. And I'm in radians, so you want to be in radians all the time in calculus. And then divide it by 4. So it's 3.43. Or I assume it's 3.43 unless I messed it up. Is that what other people got? Sure. Try it, Haley.
I don't have a calculator.
Ugh.
Oh, I can buy you one.
Yeah. How did you put it in?
Can I borrow your pink one?
I don't have it in here. So it's 3.43. So our equations then, or I mean, you could leave it really ugly, but I wouldn't. Your equation for the tangent line then would be y equals 3.43 x minus 2. I should make that smaller. X minus 2 plus, and you'd have to get the y value at 2. It's a decimal, or you could always just write tan 2 over 2. Like that. Okay, you could also write that.
Wait, why would you write? Oh,
Because to get the value, you'd actually have to type it in. Then the normal line, normal means perpendicular. So it's going to look exactly the same, except instead of 3.43, it would be 1 divided by 3.43, which is 0.29, and it would be negative. So it would be negative 0.29 x minus 2 plus tan 2 over 2. And I suppose we also could have kept the decimal as like a crazy terrible fraction if you wanted to, but you don't have to. Okay, if you'll either have a calculator or you'll just leave it as an unsolved thing. Now to check on your calculator, you just go math 8 and type in the derivative, tan x over x equals 2, and I get that 3.433 thing. So I know I was right. There's also a picture there of the graphs so that you can actually see them. Like you can graph the two lines and you can see that they're tangent and that they're tangent and perpendicular and that they touch the right point and all that stuff. So that's great. Learn the chain rule now. So we should all be very excited because we're about to use the chain rule. Okay, so the chain rule is a really, really important rule. It's probably the one you'll use the most in calculus because it's a rule that allows you to differentiate what's the word? Compositions? Anyone know what I mean? Like when there's one function inside of another function. Is that a composition?
Oh, yeah, like,
It's composition. Composites. Okay, that's the word I've been looking for. Composite functions. It's even on this right here. It says we can differentiate composite functions. So that's the word I was looking for, composite functions. So something like this one here, sine x squared minus 4. That's a composite function. It's x squared minus 4 inside of sine x. Okay, so just to be really clear about what I mean by that, by a composite function, this would be like a composite if f of x was sine x and g of x was x squared minus 4, then this function is f of g of x. Okay, it's a composite function because g is inside of f. And it allows us to do functions like this. So most functions are more complicated that we're going to be dealing with than just like a polynomial function or even just like a division or something like that. We're going to be dealing with a lot of composite functions. Even just something like if you were given a function like 2x plus 3 to the power of 7 and you asked to find the derivative. That doesn't look that hard, to be honest, right? Like that function doesn't look really crazy or difficult, but imagine trying to do that without a rule. You would have to expand it out. So you'd have to do 2x plus 3 to the power of 7, which is 2x plus 3 times 2x plus 3 times 2x plus 3 times 2x plus 3 times 2x plus 3 times, and you'd have to do that, and it would take you like a year. Okay? So instead, we have a very simple rule that allows us to do this. I'm going to kind of show it to you. So it involves sort of like substitution, but to be honest with you, I don't actually do substitution very often when I'm doing it, but they want us to show you it with substitution so you get the idea of how this was created. So this rule was created by using substitution. So what they do is they take a function like this one where they have it equal 5z minus 8, and you look for the inside part of the composite function. So here, the inside part, by that I mean the 5z minus 8. Here, it would be the x squared minus 4 is the inside part. And I'm going to just talk, that's not very formal language, but I'll talk about the inside part fairly often. So you identify that inside part, and you identify it, and you call it u. Okay? So you say u is 5z minus 8. Now I can rewrite r, and instead of writing it as root 5z minus 8, which I don't necessarily know what to do with, I just write it as root u. Okay? Then I actually know how to find the derivative of that because that's very simple. That's just the same as u to the power of 1/2. So r prime, I would drop the half. I would have u to the power of what? Negative 1/2. And now this is where the rule comes in. So what they discovered was it's not enough to just do that. You also have to multiply it by whatever u prime is. Because when we're saying r prime, we're not saying the derivative of r in terms of u. We're saying the derivative of r in terms of z. And u doesn't have a z, isn't z, so we have to also multiply by the derivative of whatever u is. So all I do is I replace u. So I'm like, okay, instead of u, I write 5z minus 8, and that's to the negative 1/2, times, and I just put what u prime would be. So what would u prime have been? 5. So I multiply it by 5. Okay, and then I can just write that more simply. So that ends up being 5 over 2, the square root of 5z minus 8, which would have been quite hard to do without this rule. You wouldn't have been able to do it. Okay, so this substitution thing, I don't actually usually do substitution. I usually won't write a u anywhere when I do these problems. I'll show you how I would do it normally. Okay, just so you get an idea of how I actually would do this and how I would expect you to do it. Okay, so my general understanding of the rule is that if I have something like that function there, first, if it's a radical, I would write it as not a radical. So I would write it as 5z minus 8 to the power of a half. Okay? And what I personally do is I look at it and I think of that I'm doing the derivative of what I would call the outside. So I'm ignoring the 5z minus 8 for now. I'm just dropping the exponent. So I drop the 1/2. The 5z minus 8 stays inside. It would be negative 1/2. And then I multiply by the derivative of the inside being 5z minus 8. So it's 5. And you see I get the exact same answer. So I don't actually think, oh, okay, I'm going to do it with a u and a u prime. If the u and the u prime make sense to you, great. Otherwise, I always just think I'm doing the outside first, and then I'm multiplying by the derivative of the inside. And then you simplify it into terms that, look a little bit better. Let's look at just some more examples. We'll look at the formal rule, and we'll look at some more examples. So this version of the rule, this version of the rule here is the one that you should know. Okay, and I'll try to explain it to you so you understand it. Now, if what it is, see, it's the derivative of the outside. So we have a function here, f of g of x, okay, that we're trying to take the derivative of. So it's the derivative of the outside function. The outside function is f, because that's the function that's on the outside. So I take the derivative of the outside function, which is f prime, and I just leave g inside of it the same. Okay, so it's like that 5z minus 8. I just left it in there. Then after you take the derivative of the outside, you multiply by the derivative of the inside. Okay, and I would say you should know this format. Like, you should be able to write this down, because it's particularly useful. They like to ask concept problems involving chain rule, and students tend to get them wrong because they don't actually know how to write this. They just know the rule. They know how to use the rule. So if you know how to write that rule down, it'll just make your life a little bit easier on some of the problems. But it's outside, inside stays the same, times the derivative of the inside. That's how I remember it. The other version of the rule is underneath there with the dy over dx. I don't find it very useful, but if you wanted to learn it, you can. It's looking at that substitution thing. So it's like if you used a u, you do the derivative of y in terms of u times the derivative of u in terms of x. It's more complicated, I would say, and I don't think particularly useful in very many situations. Okay, so I already did the rule there. I already did this one, so I'm not going to do it again because that would be really boring. Okay, let's look at a couple others. So differentiate 3x squared plus 1 to the power of 2 by the chain rule and check your answer and by expanding. So here I would do the derivative of the outside first. So what would I have first in my derivative? 2, because I dropped down the 2, right? Okay, then I keep the inside the same. So I keep 3x squared plus 1 the same. And now it's to the power of what? 1. And I could write the 1 or I could not write the 1, whatever you feel better about. So that portion of it is the f prime of g. That's f prime of g. That's what that is. Because I've taken the derivative of the outside, but I've left the inside the same. Then I multiply that by the derivative of the inside part. So the 3x squared plus 1. So what would the derivative of 3x squared plus 1 be?
6x.
So it's 6x. That part there is g prime of x. Okay, and so that's the rule, is f prime g times g prime. Okay, so I honestly, I don't think about the formula of the rule very often when I'm doing it, but like I said, it's just handy to know for future problems. Now you should always simplify. So generally speaking, I mean, every question's different, but a lot of the time you're going to be able to multiply this, and you should. So that's all multiplying. So I shouldn't write this out like this. I should write 12x times 3x squared plus 1. What should I do next? Nothing is the answer. Just leave it like this. Don't expand it. Okay? Do not expand this. Just leave it. It's automatically going to be in factored form if it's a simple one like this. If it's a longer problem, you might need to factor further, but do not expand. Okay? You should not be expanding these ever. So it wants us to check it by expanding the original function. So if I look at that original function,
Allie,
yep,
why are you only multiplying 6x and 2 then?
because they're the things that are like just by themselves. They're like both monomials, so you might as well just multiply them. Because otherwise you'd have 2 times 6x, which looks stupid. Just simplify it.
Okay.
Okay, simplify it, don't expand it. Okay, so what they want us to do is they want us to expand that and check. So if I expanded that out, I would get 9x to the power of 4 plus 6x squared plus 1. And if I took the derivative of that, I'd get 36x cubed plus 12x, and I'd factor out a 12x, and I would get x squared plus 1, or 3x squared plus 1. Okay, so I get the same thing. Okay? So it works. It's magic. It's definitely magical. Okay, let's look at some other ones. Okay, so it says, an object moves along the x-axis so that its position at any time t is greater than 0 is given by x of t equals cosine t squared plus 1. Find the velocity. So if I'm given position, how do I find velocity?
Take the derivative of it.
Take the derivative of it. So the velocity is going to be the derivative of this. So the derivative of cosine is
Minus sign.
minus sign, negative sign. So the outside here, when I'm talking outside, inside, the outside is the cosine, the inside is the t squared plus 1. So when I take the derivative of the outside, it would mean I'd write negative sine, and the inside stays the same, t squared plus 1, and then I multiply that by the derivative of the inside, which in this case would be 2t. Okay? So that if I simplify it, because you don't ever leave this thing at the end like that, bring it to the front. So it's negative 2t sine t squared plus 1. The reason that I say don't leave it out there, well, first of all, there's nobody who does math would ever leave it out there. It looks bad. But also, if people leave this, what I tend to see happen is people do really dumb things. Like they multiply the 2t through, which would be incorrect, but I see people do it. So just move it to the front so that you're not even tempted to do that. Okay, so there we go. That's our velocity. Really easy, right?
Yeah.
It is. It's great. It's really easy to do. It does get harder than this, but so this one, let's just do one more. Okay, differentiate. So y prime. What's the derivative of sine? Cosine. I keep the inside the same, and then I multiply by the inside, which would be
2x
2x
plus 1.
plus 1. Okay, and again, I would even now, I would still move this to the front if I was writing it. I would write that as 2x plus 1 times cosine x squared plus x, like that. Okay. One more. God, it's so easy though. Just like you could just do it yourself and then. What? You don't want to see it anymore. It's maybe I'll do. What? Okay. This one is a little bit harder because it has two parts. So the reason this is called the chain rule is because if you have like a function that's like a composite of a composite of a composite of a composite sort of thing, you keep doing it. Okay, you keep going with it. So here, if I was doing this one, I wanted to find the derivative of it. I would do first the derivative of the very outside. So the derivative of tan. What is the derivative of tan again? Secant squared. So it's secant squared times 5 minus sine 2t. Okay, and now I have to do the derivative of the inside. So I have that negative sine 2t. What would be the derivative of negative sine 2t? Negative, what's the derivative of sine? Cosine, so negative sine would be negative cosine. So it's negative cosine. And again, the inside, which now is the 2t, would stay the same. So it's negative cosine 2t. And then we have to multiply by the inside of that, which is 2. So you can see it gets, this is why it's called a chain rule, because the more composites you have, the more you just have to multiply by the derivative of the new inside. Okay, so this, to simplify it, you would write the negative and the 2 out front. So it'd be negative 2. And then it's up to you if you want what you want to put first, if you want to put the cosine or the secant. I'd probably put the cosine first. Cosine 2t secant squared 5 minus sine 2t. Oops. Okay, like that. Okay, so that's why it's called chain rule. Let's just do another one kind of more like that one, because that's a little bit more complicated. So if you were given something like, and I don't know if we should, no, I guess we don't have to go that hard on it. Maybe we should, though. Okay, you were given something like sine okay, if you're given something like that, okay, you do the very outside. So the very outside, you start on the very outside and you work your way in, is basically the idea. So the very outside, the derivative of that would be cosine. So I write cosine and I leave the inside exactly how it looks. So it's still 5x plus 3 to the power of 4. Then I multiply by the derivative of that. So the derivative of that, again, it's going to be a chain rule. So I drop the 4. I have 5x plus 3 to the power of what? 3. And now I have a new inside that I multiply by. The derivative of that would be 5. So that's why it's called chain. So this, you could have one with more than this, but honestly you won't see very many. But eventually you're going to be doing like quotient rules where you have to do chain rules as a part of them. Okay, so they do start to go together. Now this, if I was simplifying this, what should I put together?
5, 4.
The 5 and the 4. Okay, they should become 20 because this stuff's all multiplying, so you should write 20. Then you just leave the 5x plus 3 to the power of 3, and then you write the cosine. Okay, like that. Bless. Okay.